Hey guys, welcome on the second problem on trusses. So in this trusses problem, we'll have to find out nodal displacement, reaction forces, stress in each member, and axial elastic strain. So the entire bars is in the uniform cross section of 100 mm square and the Young's modulus of 3E5 megapascal, which is converted into 3E5 Newton per mm square. So there are four key points actually we'll have to create. So there are four bars, 1, 2, 3 and 4, and four key points. So we'll have to start from here to here and follow it with all others. So this is the plan, and let's start the structures in ANSYS. So let's go to preferences, structural, okay, go to processor, element type, add link 2D spar 1, okay, close it, go to real constant, add, okay. So the real constant set number would be 1 and the area would be, which is given as 100 mm square. Click on OK. So you can close. Go to material properties, material models, the model number 1, structural, linear, elastic, isotropic. The EX value would be, which is given as 3 into 10 power 5, which is converted to Newton per mm square as 3E5. Also, the PRXY value would be 0.27. Click on OK. Close this window. So the initial configurations has been done. Let's go to modeling and create key points. Go to key points in active CS. So let's go to the figure and mark the key points accordingly. So the first key point would be 0, 0, 0, which is initial key point. Click on apply. The second key point, which is 300 mm on x-axis and 0 on y-axis. Apply. The third key point, which is here, so it's 300 mm on x-axis and 400 mm on y-axis as well. So apply it. And the fourth key point is here, so it's 0 on x-axis and 400 mm on y-axis. So click on OK. So the points has been plotted according to our plan. So we can just zoom out and make sure it's proper. So let's connect the key points as per the plan. 1, 2, 3 and 4. So in lines, go to lines, straight line from 1 to 2, 2 to 3, 4, 3 to 4 and 4 to 2 again. So click on OK. So the lines has been created. You can just verify with this, and now we'll have to do meshing part. So as we did in the last problem, samely go to meshing, go to mesh attributes. So all lines, since all lines come under the same this thing, so the material number and material constant number would be 1 for all, and the mesh attribute has been setted. So go to size control, annual size, lines. So pick lines, or you can pick all the lines. So the element number of division would be 1. Click on OK. And now we'll go to mesh, lines, and we'll just pick all. So the meshing has been successfully completed. You can close the meshing, and we'll have to assign loads now. So properly, if you see, we have two displacement loads and one force with displacement which is acting on x-axis, where it's a rolling action. It's a constraint on y direction. So let's create this in ANSYS. So let's start giving loads. Go to loads, define loads, apply structural displacement. So we'll have to apply displacement loads on 1 and 4th key points, which is these two. On key point, just select first and second. Go click on OK. So the DOFs to be constrained will be all DOF, and displacement value would be 0. Click on OK. So this thing has been done now. We'll have to do this, which is so here in y direction it's constraint, and the displacement value is 5 mm. So we'll select this key point, click OK. In y direction it's constraint, and the displacement value is 5 mm. Click on OK. So now we'll have to create force here, which is of 100 Newton. Go to force or momentum, go to on key points, click this key point and click on OK. The value would be 100. Click on OK. So this complete thing has been done. You can verify our solution by going to solution, solve, current LS, click on OK. So the pop-up window will be showing as solution is done. Once it's shown, close it. So now we'll go to the functions which are in general post processor. Before that, we'll have to see what are the things which are asked out. So we are asked to find stress and strain. So let's define table for stress and strain in general post processor. So go to general post processor. In general post processor, go to element table, go to define table, add. So for stress, give the user label as stress, and the by sequence num should be selected, and for stress it's ls comma 1. Click on apply, and for strain enter the label as strain strain, use by sequence num, and here you should use lepl comma 1 for strain. Click on OK. So these two labels should be shown here. Verify and close it. So now let's find out the nodal solution, which is the nodal displacement. Go to plot results, counterplot nodal solution. So in nodal solution, inside DOF solution, select x component displacement, click on OK. So this should be displayed. DMX and SMX should be copied. You can go to plot control, style, size and shape, and you can enable display of element as on and OK. So the 3D would be shown. And next we will have to go to line element result. So make sure stress and stress is selected in node A and node J. Click on OK. So the minimum and maximum line stress diagram would be given. The same thing will be used for strain. Click on strain on both I and J. Click on OK. So the minimum and maximum value for line strain diagram would be given. So this should be copied. So on more, you can go to element table, select stress, click on OK. So the line stress diagram would be shown. Again, you can go to strain, click OK. So here the line strain element will be displayed and the values can be copied. So let's find out a reaction solution and list results. In list results, go to reaction solution, select all items and click on OK. So these values, which are node specific, should be copied, and the next element table data for stress, the minimum and maximum values will be given. This can be copied, and the same thing for strain and for both will be given. This can be copied. So this was all about the structuring thing of second problem in trusses. So you can animate this thing by going to plot controls, animate, deformed shape, select deform plus undeformed, click on OK. So then animation would be shown. You can stop and close it. And this was all about the second question on trusses.